So we're talking about EAP authentication today, specifically with in Wi-Fi. So first, I figured before we dive too deep into it, I'm going to be a little prideful and show you my little puppy here, and a little bit about me. So I'm a technical support engineer for 7Signal. Whoops, went to the wrong. Apparently my mouse can change slides. Did not realize that. Sorry. So customer support engineer for 7Signal. I handle everything technical support side of things. Yeah, so I have a little over a decade experience in enterprise networks, from routing, switching, firewalls, SD-WAN, load balancers, all that fun stuff, and Wi-Fi as well. I've been with 7Signal now for almost 2 years. I think it's 2 years at the end of summer. I live in the Pacific Northwest, just outside Portland, Oregon, and I have a new puppy. He's 9 months old. He's a Lagotto Romagnolo, and there's a photo of him looking all cute. So some things that we're going to talk about today, just a general intro into EAP authentication, some kind of high-level overviews of some different EAP methods, EAP-TLS, EAP-TTLS, PEAP, EAP-FAST, some advantages and why you would use EAP authentication. And I keep hitting my mouse, so I apologize. Some best practices for actually implementing EAP within your network. Also, briefly talking about how EAP authentication can impact your users and affect their experience when connecting to your network. And then also dive into a little bit of troubleshooting, some common issues that can happen with EAP authentication. So here's a kind of a high level overview of how EAP works, just in general. So kind of from left to right, the client will then authenticate to the network via open authentication, connect to your AP, that kind of thing. And then your authenticator, which is typically your AP, will then send an EAP request to that client. The client will then respond. It will be sent to the authentication server. That one also responds back with a different EAP request and response. So there's EAP requests and response in both directions, to the client as well as to the server as well. And then you'll get either a success or a failure message. So what is EAP? EAP is just a framework for authentication. It's kind of think of it as like the, I guess like the framing of a house, the studs, all that good stuff, and then you add on top of it, you add the siding, the insulation. That's all the inner method authentication pieces and everything else that goes into EAP authentication. If you want to learn more about EAP, specifically TLS related in depth, there was a very good webinar done, I believe about 2 months ago, specifically related to TLS. I don't know, Heather, if you can put a link maybe to that webinar in the chat so people can use it as a reference, but that was a good deep dive into how the TLS protocol works, how EAP works as well. This is a much more high level overview because there's way more info that I plan to cover today as well. So yeah, so it establishes a secure connection not only to the client but also to the authentication server. So it's a mutually authenticated method. So like I said, the open system authentication takes place before EAP starts. So you'll have your authentication request to join your AP, your response, and then it will be your association request and response as well. Some high-level overview of some common EAP methods. I would say the two most common are EAP-TLS and EAP-PEAP. So EAP-TLS, it uses certificate-based authentication, not only for just the authentication server, but the client as well. So during the EAP process, the client will present its cert to the authenticator saying, hey, here's my certificate. The server will then get that certificate and verify that it is matching the certificate chain that it has for its server side certificate, that it's using the same trusted certificate authority, the CA. It's what I would consider the most secure of the different EAP methods. It encrypts the entire authentication process. It also will protect your users, like their usernames, their passwords, and their session keys when they're connecting. So they're not the end user does not necessarily have to enter a username and password to connect to an EAP-TLS network. So EAP-TTLS is more, it's very similar. It's actually almost identical to EAP-PEAP. The differencing being the wrapper that the EAP authentication method is using. So instead of, that's really the only difference. So it's not quite, instead of it being kind of Active Directory or LDAP based, where you have like a database of users, there's different ways you can implement TTLS. I think the most common implementation is, think of like service provider public Wi-Fi networks are typically EAP-TTLS, where you could have a username and password to connect, but it's typically not much input from the user. You'll enter a password maybe once, and then you can authenticate to them all around. So it's very flexible because there's no certificates that need to be installed or managed on the actual client itself. Like I said, there's different authentication methods. So it can be password based, it can be token based, it can actually even be certificate based, which is interesting. But if you wanted to authenticate with a certificate, you could do that as well, but it's not required. EAP-PEAP is probably the most common, if I was to wager. It also uses a server-side certificate to authenticate. So the client will ensure that whatever server it's connecting to or authenticating against is trusted. Same thing with EAP-TTLS. You can use passwords, you can use tokens, you can use certificates. It's widely supported. Like I said during the trivia, I believe it was developed by Microsoft, so it's very easy to integrate with like Active Directory, to where you're using a username and password in your enterprise network. Yeah, all those fun things. And then there's EAP-FAST. I actually have no experience utilizing EAP-FAST. I know some people do. It was developed by Cisco. It is more widely used than just Cisco products now, and uses a combination of similar things. So they're all tunneled with the TLS, and then instead of or EAP-FAST in particular uses what's called protected access credentials, or PACs, and those are actually established, predefined from the client to the authentication server. You can actually have the PACs be auto provisioned as well, and it eliminates the need for the certificate-based authentication. And I see there's a question as well that Forrest has put in. The method that I see mostly in large companies is either EAP-PEAP or EAP-TLS. It depends on if they want to manage certificates or not. Some advantages of using EAP authentication. So EAP is a very strong authentication method. It provides a framework, like I said earlier, so only authorized users can access the network. Various authentication methods, certificate-based, username, password, tokens, and it enables the organization, or it enables the company to choose which method fits their security requirements best. So to go back on the question of which one's mostly used in large enterprise networks, it depends on what systems you already have in place. If you have your own CA servers, for example, and you can issue your own certificates. Makes sense to go ahead and issue certificates to your clients, and then use EAP-TLS to use the certificate-based authentication to authenticate and join the network. The advantages of using TLS would be that there's less input from the user because the certificate's on the machine and the machine handles the certificate or handles the authentication via the certificate without an input from the user. But if there is no certificate based, then you can default over to PEAP and then utilize the username and password that was used to log into the machine, for example, via AD. It's also, it establishes a secure encrypted tunnel between the client and the authentication using TLS. So this protects users' credentials, passwords, usernames from being intercepted as well. So you can kind of avoid some man-in-the-middle attacks that way, depending on which TLS version you're using. You want to make sure that you're using like TLS version 1.3, for example. So EAP also supports mutual authentication. So both the client and the application or the authentication server will authenticate each other. That ensures that the client, the connecting is a legitimate client, but also that the server is trusted. So that's how you guard against the man-in-the-middle attacks, for example, or the unauthorized access within your network. There's a centralized authentication and management. So it simplifies kind of the admin work and enforcing your security policies. So it can be integrated with existing user databases. Like I said, if you have Active Directory, that's a good way to implement PEAP, LDAP, or just other types of radio servers as well. It's also very flexible. It supports lots of authentication methods, inter authentication methods and protocols. And it allows kind of the organization to pick and choose based off of the, like I said, their security requirements and infrastructure. It's also scalable. So you can, instead of spinning up entirely new authentication pieces, since it's all centralized, you can have all your authentication come to one point and then scale outwards as needed. So you can have it in a small deployment, and then you can scale out for very large deployments as well. And then obviously it being compliant with security standards is a big one. So like a big one, for example, is PCI DSS. So if you're handling any type of payments with a credit card or anything like that, having them connect via a strong encrypted method to connect to the wireless is a pretty big deal. Some things to keep in mind when you're actually implementing EAP authentication. Kind of, I don't know if these are step by step, but there are definitely steps to consider. Is assess what your requirements are. So assess what your security requirements are of your network. Consider how you're handling sensitive data, how it's being transmitted over the network, any type of compliancy requirements that you have. But you also need to think about what level of user authentication is actually required. And then once you have those requirements defined, then you can actually choose, you can choose the method to use with that align with your security requirements. So whether it's TLS, TTLS, PEAP, you can evaluate the strengths and weaknesses of both, or not both, of all of the methods, and then choose which one meets your needs specifically. So which one meets your requirements, whether or not you require certificate-based authentication, and also to keep in mind what support you need for your infrastructure as well. And then prepare the infrastructure. So ensure that you have all the required resources within your environment. So So like your radius servers, your CA servers, your directory services, configure all of those components to then utilize the actual authentication. So set up your CA, use third party, or sorry, the certificate management pieces of this is if you end up using certificate based, you want to set up your CAs, have certs for both the authentication server, but also for your client devices, and then have a process to enroll those devices. So how are they getting their certificates? How are they renewing their certificates? What are you doing to revoke certificates if a user is no longer with the organization, that kind of thing. Then you would want to configure authentication servers. So your radius servers, make sure that your server supports the EAP method that you have chosen. So you want to have policies in place for authentication, authorization, and accounting, and then ensure that the authentication server is integrated within your network. So the most experience that I have in terms of authentication servers is with Cisco ICE. So having that and then going through the whole process of defining policies, applying those policies to specific authentication points, having the certificates on your nodes within ICE. So if you're doing like a clustered deployment where you have policy nodes and all that fun stuff, making sure that all of the nodes within your environment are configured and ready to go. And then once you're ready to configure your client devices, so think laptops, smartphones, anything an end user would typically be using, this is where things get a little more cumbersome potentially. So if you're having to install certificates, there are easy ways to do it. So if you have an MDM solution, that's an excellent way to push out certificates to smartphones. Same thing with laptops as well. So having a way to enroll those clients and get certificates on them if you're using TLS is kind of vital. So, and then next you want to actually test before you deploy it. So test, make sure the authentication is working, that you're able to connect, and then roll out the EAP implementation to your network. I would do it in kind of a phased approach. So kind of in phases, roll it out instead of just one blanket push. It obviously depends on the size of your network as well. And then monitor, make sure everything's working correctly, but also maintain it. So you want to do updates, you want to review the logs of what's happening, make sure you're saving the logs. And then you can also utilize some products to verify connectivity and verify that things are working as intended. And then lastly, user education and support. So you want to make sure that especially if you're going from like a pre-shared key network to EAP authentication, you want to make sure your end users are aware. There's nothing worse than deploying an entirely new way to connect to the network that interrupts their workflow. So making sure that they know, communicate what's changed, why it's beneficial, and then offer them some resources or even assistance if they need to do something on their devices to connect to the network. And then some best practices, kind of the same. You just want to, or very similar to the implementation steps that I laid out. You want to plan and design your network accordingly. That's very big in terms of Wi-Fi. If you have a poorly designed wireless network, you're going to have problems no matter what they are. They could be authentication issues, but they could just be bad factors or bad design choices. So you could not have enough coverage. You could not have enough capacity. Your user density might be a little screwed up to where all of your users are in like one area. So the rest of your network is not being utilized at all, and they're all in a single conference room, for example, that has one AP, and now you're having other issues that are appearing as though they could be authentication issues, but they're actually just poor wireless issues. Make sure you're choosing the appropriate EAP method. So if you're having issues deploying certificates onto clients, obviously I would not recommend choosing EAP-TLS. I would choose something a little easier. And vice versa. If you have no issues deploying certificates, why not use EAP-TLS? It's less end user capable or end user impacting. It's easier for them to just easily connect. Yeah. So I would recommend certificate-based authentication. It provides the strongest level of security, in my opinion. It uses known certificate authorities, so you can have like DigiCert, for example. There's other third-party vendors out there. That's the first one that comes to my mind, at least. That sign a certificate and say, yes, these are legitimate certificates that are being used. And the client and the authentication server also have to be within the same certificate chain. Yeah, so then you want to centralize your authentication server. If you deploy a centralized server, it's just easier for scaling specifically. It also makes handling authentication requests easier. It centralizes the management of the servers. It allows for security policies to kind of be consistent across the board. It also helps with user management as well. Configure strong security policies. You're only as good as the policies that you have defined. So you want to make sure that you're enforcing password complexity, that account lockout policies are established, session timeouts, all that fun stuff that ends up impacting your user experience as well. But you can think about like multi-factor authentication as well to enhance security. Enable logging monitoring. Like I said earlier, you want to make sure that you're saving logs and reviewing those. And just kind of best practices for networks in general. So segmenting your network. You can segment off more sensitive areas from less sensitive areas. You can use that simply by using different VLANs, or you can get a little more complex as well, where you have like DMZs throughout your network. It depends on what you're doing exactly. Perform testing and validation. So you want to test to make sure your authentication is working and validate that it's continuing to work. Sapphire does that, for example, for you. And I'll dive into some KPIs a little later on what you can actually look at using Sapphire that we have. And like I said earlier, providing user education, you can never communicate too much to your end users. And then update and maintain. You want to keep network equipment updated using firmwares that are updating and patching security issues, but also updating your policies. Maybe something's changed where your policy isn't or needs to be updated. So not just your hardware, but also the policies you have in place. And then the impact that EAP can have on users. So it increases your authentication time. So it potentially can cause users to have a delay in connecting to your network. Depending on the EAP methods that users may be required to enter in additional credentials. So instead of having a pre-shared key just saved, it's possible they have to enter their username and password. There are ways to minimize the user input required, but it is possible that they will have to input more than what they're used to. It definitely adds some complexity to your network. So you have to look into make sure everything's compatible, make sure everything's configured correctly. So it depending on the method you're using, it could require specific software being installed on the client. I believe EAP-FAST, I don't know if it requires any Connect client. When I have seen it, it did the way that it was deployed, it used the any Connect client to establish the connection back. So that's something to keep in mind as well. And like I said earlier, educating your users. So that you want to make sure that they are aware of what's needed and what's not. Not only for them to connect to the network, but also to prevent potentially connecting to a network that isn't yours. Maybe someone is advertising your network in a rogue environment, and when they connect, they see, hey, this certificate isn't trusted. Should I continue? You want to make sure that your users know not to connect to a non-trusted certificate network, that kind of thing. One thing that it also does is it provides some seamless roaming, which is a good benefit. So you can, once you're authenticated, if everything's configured correctly, you can roam between your APs without having to fully re-authenticate. So it's uninterrupted connectivity from an end user standpoint. So it adds that level of convenience. The biggest benefit is the fact that added security, but also that trust factor to where you're verifying that certificate that the server's presenting to you is valid. Some basic troubleshooting tips, and these are kind of more high level as well. These work for troubleshooting any type of issue. First, you need to gather what information is relevant to the issue. So what symptoms the end user is experiencing, what users are affected, what devices are affected, and then you can kind of narrow down what you're looking at in terms of trying to troubleshoot and fix that way. So you'll want to verify network connectivity. If it's having authentication issues, does it have network connectivity at all, or is it just not able to authenticate correctly? Can you connect to other networks? Can you access other resources? Signal strength, stability of the Wi-Fi connection, all that fun stuff. Check the EAP method in the settings, verify that the end user device is configured correctly. It's configured to use the correct EAP method. It's configured to use the correct settings, correct certificate, authentication protocol. Yeah, you want to make sure that they match both the client and the authentication side. You want to test different devices. So if only one device is having issues, but the other ones aren't, could be an authentication issue, could be a configuration issue on that type of device, or it could just be that device is not compatible with whatever EAP method that you've selected. Verify your credentials, verify your certificates, double check username, passwords, make sure your digital certs used. Yeah, make sure they're valid, they're not expired, that kind of thing. Check the logs. So this is why saving logs is pretty important. You want to verify and review, look for error messages, failed authentication attempts. You can also look for specific codes or messages that can give you insight into what exactly is going on with the authentication itself. Analyze the network traffic. This is where getting like a packet capture is helpful. You can identify any like errors within the process, look for handshake failures, retries, anything else that's a little weird with the packets themselves. And then just review the infrastructure. So make sure that you're able to reach the authentication server, for example. That's kind of important. So you want to look for connectivity problems, power outages, misconfigurations on a switch, a router, all that fun stuff. And then some tools that you can use to help with these troubleshooting. Like I said, packet capture, so you can use like Wireshark, TCP dump. Our Sapphire Eye also captures packets for you as well. So you can use anything to capture packet and then load it into Wireshark or any other analyzer that you have to view those packets. Like you can use a network analyzer specifically. So think like an NPM, for example. SolarWinds has one. Yeah, and you can use that to then verify your network traffic, look for authentication issues, monitor up-down status of your routers, switches, things that are connecting to those servers. Look at logs. Some certificate management tools exist, so like OpenSSL, Microsoft Certificate Services. They can help you verify certificate if they're valid. You can check the full chain of the certificate as well, and then just verify proper configuration on that endpoint. Vendor documentation is great. You can dig into the docs and then see if they also offer any type of troubleshooting guides, knowledge bases, where you can find some potential solutions, find some assistance as well. Network configuration review, kind of just make sure that all your configs are accurate, consistent, but also that they're all compatible. Firmware, software updates, you want to make sure that the things are up to date, that you don't have maybe you're running into a software bug that's causing some type of authentication issue. So the manufacturers will release updates for issues, improving compatibility between different EAP methods, and also some bug fixes. One thing that a lot of people overlook is having good change management. If you implemented a change that then broke authentication, if you have that documented, it saves you a ton of time having to figure out what exactly was changed to cause all of these issues. So having a controlled change management practice and documenting your changes, conducting changes, testing them in a non-production environment, all help in terms of troubleshooting and finding those issues. Another great tool is, like I said, the Sapphire Eye that we offer. And I'm going to dive into some KPIs as well. So the Sapphire Eye will authenticate to your Wi-Fi using whatever EAP method you're using. So if it's certificates, we can load certificates onto the Eye and have it authenticate, as well as using username and passwords. And we verify connectivity as well. So this is one KPI that's monitoring how long it's taking to that open authentication. So before EAP even starts, how long does it take for us to authenticate just to the AP to establish that communication to then start the EAP authentication piece? And you can see here the time in milliseconds on it, how quickly a client is able to connect to your AP. So some client or some APs were able to connect in this example at 75 milliseconds, but other ones it's 500 milliseconds. So that adds to your client experience. And then we actually get into the EAP authentication process, or the radius phases, as we call them within Analyzer. So phase one is that time it takes between that open authentication piece and the start of the EAP authentication. So how long the EAP request is taking between us authenticating to the AP and then the client receiving that initial request. And then phase two is how long it's taking for the EAP authentication server to propose its EAP method to the client. And then phase three is the time since that proposal to when the client's actually accepting it. And again, all these are in milliseconds. So you can see that these range from 3 to 4 milliseconds. So it's fairly quick. And then phase four, this is how long it's taking for the client to verify or validate that the peer certificate or the authentication server certificate is valid. So this is very beneficial because you can see some spikes here in this example that I pulled, where most of the time we're validating the the certificate within 300, less than 500 milliseconds, but there are some spikes where it's a second and a half that it's taking for us to actually validate the certificate. And then here is the time between the validation of the certificate, the peer cert, and the time it takes for the EAP authentication to actually be successful or to finish, to complete. We also will show you the authentication status codes. So this one, for example, is status code 0. And then vendors provide some charts for you to know what the status codes are. So I pulled this one from Cisco. Status code 0 just means it was successful authentication. But there are other status codes that could potentially pull up as well. And then you also will see deauthentication codes. So same thing with auth codes. In this example, all the ones I saw were code 3. And then this chart, code 3 just means that the client had left the BSS or the area and just deauth itself that way. And then we also will monitor how many EAP authentication attempts have happened. So this is nice, so you can see if there is an issue, are there EAP authentication retries happening, that kind of thing. And you can see that it's spiking between having the one, but also we're having to do some retries as well, to where we're having 2 authentication attempts within a given time, which just increases that authentication time in total that an end user's having to wait before they can start accessing resources. Another thing that's nice to see is validating that the correct EAP method is being proposed and being used by the client. So there's, again, another chart for you to look at. So all the different EAP methods have a specific number that's associated to them. So here's the EAP method types. And then number 13 is EAP-TLS. So, and that's it. So Heather, do you want to
run some Q&A for you?
Yeah.
Let's do it. Okay, we've got some in here. Thomas asks, I've heard that PEAP will not be supported in Windows in the near future. Can you shed some light on this?
That's the first time I've heard that. I don't really know a whole lot about not being supported in Windows. I can definitely look into that though.
Yeah, definitely. If we figure it out, I'll put it in the follow-up email. So Jack, if you hear anything before I get
I'll do some research today, look into it, and then send you a note so you can include it in the follow-up email.
Perfect. All right, Fang asks, if you use only the server side of authentication, EAP, TTLS, etc., are they still considered as mutual authentication?
Yes, in my opinion, because you're authenticating to the server via a username, password, or a token, or something like that, and then you're validating the server that you're connecting to via its certificate. So with PEAP, with TTLS, there is a certificate on the authentication server that needs to be validated.
Gotcha. Great. And then we have an anonymous attendee who says, this is a lot of acronyms, how does EAP-SIM and EAP-SIM AKA fit into this?
I actually do not know EAP-SIM or EAP-SIM AKA, so another one that I will have to look up.
Yep, we'll include that one too if we get some for you. Sweet. All right, that's it. Oh wait, there's some here. I think
is there anything in the chat?
Yeah, I think we've got one from Maria. Can you talk about the 367 certificates expiring date? If there's a way to reissue it so that the endpoints don't need to be touched, is there a way to do this? They would still need to use username and password to get onto the Wi-Fi network. I'm not sure if that's really a question.
I can talk about some things. So I know from previous jobs where certificates have expired, particularly for like an end user that works remote and you use EAP-TLS to connect to the Wi-Fi in the office. Their certificate expires when they're at home, and it does not get, the new cert does not get sent to their machine. Sometimes that's an issue that I ran into. For whatever reason, I think the certificates were being pushed through group policy in this environment. So if they were connected to the network, the new certificates were automatically sent to them anyway. But if it expired when they were not connected, there was not a way to push the cert unless that user came into the office, and then the easiest way was just hardwire them into the network, and then they connected via AD. They got their new updated certificates via group policy and were pushed that way.